Galileo Galilei was an Italian mathematician, physicist, and astronomer, born on February 15, 1564, in Pisa, Italy. He was the oldest of 6 children, and his father, Vincenzo Galilei, was a musician and music theorist. From an early age, Galileo showed an aptitude for mathematics, and by the age of 17, he had developed a keen interest in astronomy. In 1581, Galileo enrolled at the University of Pisa to study medicine, but his true passion lay in mathematics and physics. He soon began to study the works of Archimedes, Euclid, and other ancient Greek mathematicians, which helped him develop his own theories about mechanics and motion. In 1585, Galileo's father arranged for him to teach mathematics at the University of Pisa. However, Galileo's unorthodox teaching methods and his rejection of Aristotelian physics led to conflict with the university authorities, and he was eventually forced to resign his position. Galileo then turned his attention to private research and teaching, and in 1589, he was appointed as the chair of mathematics at the University of Pisa. Over the next few years, he developed many of his most important theories and discoveries, including his law of falling bodies and his principle of inertia. In 1592, Galileo moved to the University of Padua, where he would spend the next 18 years teaching mathematics and physics. During this time, he continued to make important contributions to both fields, including his work on the properties of matter and his studies of the motion of projectiles. In 1609, Galileo heard of the invention of the telescope, and he quickly set about building his own. Within a year, he had developed a telescope that was capable of magnifying objects up to 20 times their normal size. With this device, Galileo was able to observe the moons of Jupiter, the phases of Venus, and the mountains and craters on the moon's surface, among other astronomical phenomena. Galileo's telescopic observations provided evidence that supported the Copernican model of the solar system, which held that the Sun was at the center of the universe and that the planets orbited around it. This was a direct challenge to the Aristotelian and Ptolemaic models, which placed the Earth at the center of the universe. Galileo's support of the Copernican model put him at odds with the Catholic Church, which considered the theory to be heretical. In 1610, Galileo published Sidereus Nuncius, Starry Messenger, a book that described his telescopic observations of the Moon, Jupiter, and other celestial bodies. The book was an instant success and helped establish Galileo's reputation as a leading astronomer. Galileo's support of the Copernican model, however, brought him into conflict with the Catholic Church. In 1616, the Church declared that the Copernican theory was heretical and prohibited Galileo from teaching or advocating it. Despite this, Galileo continued to write about and defend the Copernican theory. In 1632, Galileo published Dialogue concerning the two chief world systems, which presented arguments for and against the Copernican and Aristotelian models of the universe. The book was seen as a direct challenge to the Church's authority and was condemned by the Inquisition. In 1633, Galileo was summoned to Rome to stand trial for heresy. He was accused of teaching and advocating the Copernican theory, which had been declared heretical by the Church. Despite his defense and his insistence that he had not intended to challenge Church doctrine, Galileo was found guilty and placed under house arrest for the rest of his life. During this time, he continued to write and work on scientific projects, including his studies of motion and mechanics. Galileo's house arrest did not prevent him from making further contributions to science. In fact, it was during this period that he completed some of his most important works, including 2 new sciences, which laid the groundwork for the modern study of mechanics. Galileo died on January 8, 1642, at the age of 77. His work laid the foundations for modern physics and astronomy, and his support for the Copernican theory was a critical step in the scientific revolution of the 16th and 17th centuries. Despite the controversy surrounding his work and his conflict with the Church, Galileo's contributions to science have been widely recognized and celebrated. He is considered one of the greatest scientists in history, and his legacy continues to inspire and influence scientific research to this day. In questions of science, the authority of 1,000 is not worth the humble reasoning of a single individual. This quote highlights Galileo's belief in the importance of reason and empirical evidence over blind adherence to authority or tradition. He was a champion of the scientific method and believed that knowledge should be based on observations and experiments, rather than on dogma or received wisdom. I do not feel obliged to believe that the same God who has endowed us with sense, reason, and intellect has intended us to forego their use. Here, Galileo expresses his belief that science and religion need not be at odds. He saw no contradiction between his scientific discoveries and his faith in God, and believed that the pursuit of knowledge was a way of honoring the gifts that God had given to humanity. Infinite is the power of the Creator, who has created this vast machine, and still governs it with immovable laws. Galileo was struck by the beauty and order of the natural world, and believed that the laws of nature were a reflection of the divine order that governed the universe. He saw science as a way of uncovering the secrets of this divine order, and believed that by studying the natural world, humans could come to a deeper understanding of God. All truths are easy to understand once they are discovered, the point is to discover them. This quote reflects Galileo's belief in the power of reason and the importance of scientific discovery. He saw science as a way of unlocking the secrets of the universe, and believed that with careful observation and analysis, anyone could come to a deeper understanding of the world around them. Measure what is measurable, and make measurable what is not so. Galileo was a pioneer in the field of experimental science, and this quote reflects his belief in the importance of precise measurement and observation. He believed that by measuring and quantifying the natural world, scientists could uncover the underlying laws that govern it, and make new discoveries that would advance our understanding of the universe. We appreciate your support in watching our videos. If you enjoy learning about political, business, writer and science leaders' biographies and quotes, please consider subscribing to our channel and giving us a thumbs up to help us grow and continue bringing you valuable content.